Okay. Bismillahirrahmanirrahim. Bishwali Salim Sibli and Biwala Lokatam Lisani Koli. Assalamualaikum little kids. This is Shiraz Abdullah and today we are going to discuss nuclear fission. The topic of our discussion is nuclear fission. You know, the word fission means splitting. The word fission means splitting. Whenever a heavy nucleus splits into lighter nuclei known as nuclear fission. That process in which a parent nucleus converts itself into a daughter nuclei is known as nuclear fission. Do remember, in this nuclear fission, a lot of energy is also released, and in this process, 3 neutrons are also emitted. But do remember one thing. Nuclear fission can be defined as that process in which a parent nucleus converts itself or splits itself into 2 daughter nuclei known as nuclear fission. In other words, we can say the process in which heavier nucleus converts itself into a daughter nuclei known as nuclear fission, and the word fission means splitting. Okay, in this process basically a lot of energy is released in form of gamma rays, and in this process 3 neutrons are also ejected. Now the question arises that how a parent nucleus converts itself into a lighter nuclei and how a heavy nucleus can convert itself into a daughter nuclei of intermediate size. Okay, we can also say that the process in which large size nuclei converts itself into an intermediate size nuclei known as nuclear fission. Okay, and how we do? We have to fall slow moving neutrons on the parent nucleus or heavier nucleus. We have to fall slow moving slow moving neutron on the parent nucleus or heavy nucleus. Then it is going to convert itself into a daughter nuclei, or in other words, you can say it will convert itself into a lighter nuclei. And 3 neutrons further will eject over here, and a lot of energy will be also released. Now, do remember one thing. This concept of nuclear fission was discussed by Otto Hahn. It was discovered by Otto Hahn on 17th December 1938, and Fritz Strassmann. These two were the scientists who discovered basically this nuclear fission phenomena. And further theoretical explanation of this nuclear fission, was given by 2 more scientists. Lacy Meitner on January 1939 and Otto Robert Frist. Right? So these 2 were the scientists who gave a theoretical explanation of this nuclear fission phenomena. Okay, now what happens? Look, we have an unstable nucleus over here. For example, uranium we take 235, uranium 235. 92. 92 is the atomic number of the uranium and 235 is the atomic mass of that uranium. Okay, what we do, we fall slow moving neutrons on it. Okay, and 1 to the base naught. This shows you what? Neutron. Okay, this shows you what? This is neutron. This showing you what? This is neutron. It is fallen on the parent nucleus. This is what? This is parent nucleus. Or we can say heavier nucleus. Okay, now then it moves to an excited unstable state. Now 1 neutron is added in this nucleus of 235 uranium, so mass number will change to 236. Why? Because 1 neutron is extra added in uranium 92 235. Okay, this is we put a star over here. This star shows you a highly excited state, unstable, highly excited state, and this is excited state that lasts for 10 power minus 12 seconds. That lasts for 10 power minus 12 seconds and has a very less half-life, and it is for a very short period of time, 10 power minus 10 seconds, and then it converts itself into 2 lighter nuclei, for example X and Y. These 2 lighter nuclei are basically over here it is barium, and then we have krypton with 3 more neutrons over here, with 3 more neutrons and much amount of energy in form of gamma rays. Now look, we are going to show practically like how this nuclear fission takes place and which sort of lighter nuclei are forming over here. The same reaction I am going to write once again over here. Look, this is slow moving neutrons. It is bombarded on uranium-92 235. For time being, it is very excited, and let me show that stayed by star and mass number will turn to 236 92, and two lighter nuclei will form over here. The first will be barium and second will be krypton with 3 more neutrons and Q amount of energy. Q amount of energy will be released over here. Barium 141.56. 141.56. 141 is the mass number of barium and 56 is the atomic number of barium. And then we have krypton 92.36. Krypton 92.36. Right? So these are two lighter nuclei. This XY was daughter nuclei. Daughter nuclei, you can say, or you can say lighter nuclei. Lighter nuclei. Okay, so this slow moving neutron is bombarded on uranium-92 235 and it gave you uranium-92 236. It's a very unstable state. It has a period of 10 power minus 12 seconds. After that, it converts itself to barium and krypton and releases 3 more neutrons in that process and a very large amount of energy. Let me show that large amount of energy by Q. Okay, so this was all about nuclear fission. So this was all about nuclear fission, and let me summarize today's work. In today's lecture, we have discussed nuclear fission. The word fission means splitting, and we can also define nuclear fission as the process of splitting parent nucleus into into daughter nuclei known as nuclear fission. We can also say that the process of splitting heavier nuclei into lighter nuclei known as nuclear fission. And it was discovered by Otto Hahn and Fritz Strassmann. These two are the scientists who discovered it, and then theoretical explanation was given by Meitner and Robert Frost, right? So these two are the scientists who gave theoretical explanation of that, right? Now, this is the general expression, this is the general expression, and this is a specific expression for that, right? And exactly you have to write both, okay? And this is slow moving neutron, this is uranium-92 235. When this slow moving neutron is bombarded or absorbed by uranium-92 235, one neutron is extra added in the nucleus of uranium-92 235. So atomic mass number will change and it will return to 236. This is highly unstable state, and it lasts for 10 power minus 12 seconds, and then it splits into 2 more daughter nuclei X and Y. Now this X and Y I am going to show over there. This is basically barium, this is krypton, we will show over there. So generally I am representing by X and Y over here. This is daughter nuclei and 3 neutrons are ejected and much amount of energy is also released in this process. Okay, and if you consider specifically, so over here this barium forms and krypton forms, and these two are considered as our daughter nuclei, right? So this was all about today's lecture. Hope you have enjoyed the lecture. Thanks for watching.